How solar flares affect our planet, exploring the power of the sun's magnetic field. Solar flares have been a part of our solar system for millennia, but only recently have scientists begun to understand their true power and the effects they can have on our planet. In this article, we'll explore the power of the sun's magnetic field and how solar flares can affect our planet. Solar flares are powerful bursts of radiation that are released from the sun as a result of intense magnetic activity. Solar flares occur when magnetic fields on the surface of the sun become twisted, allowing huge amounts of energy to be released in a burst. The energy released by a solar flare can be many times greater than the energy released by a nuclear bomb and can travel across interplanetary distances to reach the Earth. Solar flares are classified according to the X-ray energy they produce. The smallest and weakest flares are called A-class flares, while the largest and strongest flares are referred to as X-class flares. In terms of energy output, X-class flares are the most powerful type of solar flare and can cause the most significant effects on our planet. These flares can be seen as bright flashes of light on the sun's surface, but their true power lies in the radiation they release. The radiation released by solar flares can travel across interplanetary distances and affect our planet in many different ways. The solar wind is a stream of charged particles that is constantly emitted from the sun and interacts with the Earth's atmosphere. The solar magnetic field is a region of intense magnetic activity on the sun's surface. When the solar magnetic field becomes twisted, it can cause powerful bursts of radiation to be released in the form of solar flares. Solar flares can have a wide range of effects on our planet, from the visible light they produce to the powerful radiation they emit. The most visible effects of solar flares are the bright flashes of light they produce on the sun's surface. These flashes can be seen from Earth, and in some instances, they can be bright enough to be seen during the day. The most significant effects of solar flares, however, are the powerful bursts of radiation they emit. This radiation can travel across interplanetary distances and reach the Earth's atmosphere, where it can interact with the molecules in the air. This interaction can cause a variety of effects, including increased levels of ultraviolet radiation, increased radiation exposure, and increased levels of charged particles. Solar flares can also have an effect on our planet's magnetic field. The Earth's magnetic field is a region of intense activity that is constantly being monitored by scientists. When a solar flare occurs, it can, if strong enough, cause a disruption in the Earth's magnetic field, resulting in disruptions in communications, navigation systems, and power grids. This magnetic field, also known as the magnetosphere, helps to shield our planet from dangerous radiation and charged particles that come from space. The magnetosphere has been weakening and is currently at about 80 to 90% of full strength, depending on which scientist you talk to. When a solar flare is strong enough, it can get through the Earth's magnetic field, resulting in disruptions in communications, navigation systems, and power grids. Basically, anything electronic. In addition, solar flares can cause fluctuations in the Earth's magnetic field, which can affect the behavior of animals, birds, and other creatures that rely on the Earth's magnetic field for navigation. Solar flares can also affect the Earth's atmosphere, resulting in increased levels of ultraviolet radiation, increased radiation exposure, and increased levels of charged particles. Solar flares can have a profound effect on our planet's atmosphere. This can have a variety of effects, ranging from increased temperatures to increased levels of ozone depletion. Solar flares can also affect the Earth's climate. The radiation released by solar flares, in conjunction with a weakening magnetosphere, can interact with the molecules in the atmosphere, resulting in increased levels of ozone depletion. This can lead to increased temperatures, increased levels of air pollution, and increased levels of ultraviolet radiation. Solar flares can have a wide range of effects on our planet, from the visible light they produce to the powerful radiation they emit. To protect ourselves from solar flares, it is important to understand their effects and take the necessary precautions. One of the best ways to protect ourselves from solar flares is to stay informed, although I doubt you will hear any warnings in the mainstream media. Solar flares are a lesser danger to us than a CME, or coronal mass ejection, but that's a topic for another day. A solar flare can reach Earth in as little as 8 minutes, so advance warning would be impossible and of little help anyway. A CME on the other hand takes from hours to as long as 5 days to reach us. Even if it was big enough to call a planet killer, which really means a grid killer, I personally doubt they would warn us. I'd love to be wrong on that. Astronauts are especially vulnerable and should always be equipped with proper radiation protection equipment. It is important to understand the history of solar flares to better understand their effects on our planet. Solar flares have been a part of our solar system for millennia, and a few of the most powerful flares in history have been recorded. The most powerful solar flare ever recorded was the Carrington event, which occurred in 1859. This event was so powerful that it caused disruptions in telegraph systems around the world and caused aurora, northern lights, to be seen as far south as Cuba. Since that time, there have been several other powerful solar flares, including the 1989 Halloween storm, which caused major disruptions in satellite communications around the world. Solar flares are a natural part of our solar system and will continue to be a part of our lives in the future. As we continue to explore the power of the sun's magnetic field, scientists will be able to better predict and prepare for solar flares. In the future, we may be able to use advanced technology to protect our planet from the effects of solar flares. This technology may include advanced shielding materials, improved radiation protection equipment, and improved communication systems. To protect ourselves from solar flares, it is important to stay informed and take the necessary precautions. My definition of precautions are to be as prepared as I can be for a long period of time without an electric grid. No one knows the probability of another Carrington event happening, but the possibility is indisputable. As far as I know, no one can say with certainty what the extent of that happening would be on our grid. It is widely accepted, however, that in a total grid down scenario it could take months if not years to restore power. Could you survive that?